right, so we are going to calculate current today. We are going to use these variables. Current is I in all of our formulas. So you can see down here for the formula, our little cheater triangle, that we don't have a C for current. That's going to be one that we really want to kind of stick in our brain, that current is I in the formula, and it's measured in amps. We've already had that in some bell ringer questions. Power is P and is measured in watts. So at least the P and the power go together, and the unit is watts. Voltage is V, and it is measured in volts. So if we look at the formula, it says we're going to calculate current. But the formula that most people think about is that power equals current times volts. So that's what we'll start writing in our notebook. And of course, we'll have our cheater triangle to help us navigate that. But we're going to go ahead and start our notes with calculate current. All right, so our formula, that the way that it's most of the time written, is power equals current times volts. And so looking at that, that might not mean anything to us. We probably want to go ahead and write the words. And just remember that I is current, electrical current. And voltage is our difference in potential energy. So we'll see that power is in watts, which is a W. Current is in amps or amperes, which is usually denoted with an A. And voltage is measured in volts. So sometimes we use that word interchangeably, and it's often denoted with a V. So power equals current times volts, and we can go ahead and put our sort of cheater triangle right here. Power is on the top. Current and volts is over here. So just for clarity, we can go ahead and write down our division. If we need to know current, we're going to know it's going to be power divided by voltage. If we need to know voltage, it's going to be power divided by current. And then, of course, if we need to know power, it is current times voltage. Okay? All right, so let's go ahead and do some practice problems that we can find the practice problems. And like I said, I will be checking your notebook today. So if you're in class, I'll be able to see that. If you're not in class, you need to submit somehow to show me that you did the work. So we're going to open our practice problems, and we'll zoom in just a little bit to try to make sure we can see them on the screen. And we'll just kind of start doing some problems here as examples. Number one, I always like to write my variables. It kind of helps me keep everything organized, especially when we start doing the word problems that go along with them. But how many amperes does a 100-watt bulb require when operating on 120 volts? Okay, so our question words right there at the beginning. How many amperes? Well, what part of our problem is amps? That's current, so that's going to be the I. It's a 100 watts bulb require when operating on oh goodness, I am talking and trying to write at the same time. I just said our question word was how many amperes, and so that's what we're trying to find. And we have a 100-watt bulb. That's where watts goes, because power is measured in watts, and then operating on 120 volts. So now we look at, okay, what do I actually have? My amps was my question. How many amps? I'm looking for amps. So when I go back to kind of my cheater triangle, I'm going to say, well, I need amps. So power divided by volts is what I'm looking for. And so I can just plug in after that. And then we can pull up our calculator to make sure. that we have the correct calculation. So 0.83, we can round it off. And if we look at our significant digits, we know that we really only have one significant digit with our power number. So we could round off to just one significant digit of 0.8. And then what unit is that going to be? Well, current is in amps, so we know that we can just put an A there, and that's going to be the correct unit as long as we're matching up our variable with the unit that it belongs with. Well, I mean, the most accurate answer is the one that matches in significant digits, but a lot of times your questions for this class are going to be multiple choice, so you just got to find the one that actually matches. Like if in the question it said 0.83333, that is still a correct answer, but then go back to the question and say, does it say significant digits? Is there one that says 0.8? Because that would be the most accurate. So you kind of have to think through exactly what those answer choices are and what the question really says. That's a good question. All right, let's look at number 2. And this one is actually asking how many amps as well. So I think we'll skip down to one that is asking a different question. All right, number 3 asks for watts. So we will kind of get ourselves an example of each one and then look at our expectation. Let's see if I can write them in the right places this time. All right. So how many watts? Well, what does watts go with? Watts goes with power. So we know that power, that's our question word. How many watts already? How many watts are used in a light bulb that draws 2 amperes at 120 volts? All right, so it draws 2 amperes. Well, neither one of those is A, so I have to know that current is I and current is amps. Okay, so those go together. So I know that 2 amperes goes right there at current at 120 volts. Why do you think they keep using 120 volts? It's a very common voltage in what we have. All right, so then I look, all right, well, I need power. So if I point at power, I say what's left, I need this. So I need to do current times volts. And that's typically the way that we see the formula written. So power equals 2 amperes times 120 volts. We could probably do that one in our head. That would be 240, but it never hurts to calculate just to check and not make a silly mistake. 240. So power equals 240. What unit goes with power? Watts. Okay, so kind of getting those units straight is really an important part. So now we have a formula for current, we have a formula for power. Let's go ahead and look for a problem that asks us about volts. And actually, before we look for one that's powered by volts, number 4 sort of throws a wrench in the works a little bit. So let's go ahead and look at it. And that was actually 3. So number 4, it says, let's write our variables. Number 4, it says a device that is powered by 2 1.5 volt batteries draws this many amperes, 0.0015 amperes. What is the total power used? So our question is, what is the power? And it has 2 1.5 volt batteries. So what do I put for volts? Well, if I have 2 times 1.5, then I'm going to have 3 volts. So kind of knowing that it's an additive, in this case, we could multiply because we have 2 sets of 1.5. So 2 times 1.5, or 1.5 plus 1.5, gives us 3 volts. And then it is drawing the 0.0015 amps. Right? So that idea that we just add the number of volts together for the battery is really important. And again, we're looking for power. So power equals I times V. We can look back at what we did before and get that. And now we're just plugging it in. And so we'll pull up our calculator just to make sure that we don't mess up our Why did I put a W there? Power is measured in watts, so that's important. All right. Okay, thank you. All right, so let's find a question that's asking us for volts. 120 volts. What is the voltage? Number 10. Number 10 asks us to find voltage, so we will go ahead and do number 10 together, and then you will be responsible for some on your own. And we're going to use this same formula because that's what we're learning today. So the electric power consumed by a circuit with one light bulb is 6 watts. The current in the circuit is 4 amps. What is the voltage of the circuit? So this one is pretty straightforward. It's asking us for volts. That's our question word. And it tells us the power consumed is 6 watts. So we don't even have to really ask ourselves about that one. And the current in the circuit is 4 amps. So now we can look and say, all right, what is volts? If I go back to my cheater triangle, volts is this one I need. So I have power divided by current. It's hard to say current when you see that I, but it is definitely important to connect current and I. Okay, so then I can just plug them in. 6 watts divided by 4 amps equals, and don't be afraid to use your calculator. We don't want to make any silly math mistakes. So 1.5 is our answer. Okay, so the total voltage of the circuit is 1.5. All right. So we did questions 1, 3, 4, and 10 together. If we kind of look at the worksheet that is there, there are 11 questions on the worksheet. So we have done 4. I would like to see you do 4 more. So you need to do 4 more on your own, and I will check that in your notebook here in just a second.